Welcome, everyone. I believe this is actually our sixth CT Tech Talk, and I'm very excited, to be the moderator of this Tech Talk, and I have Chris here with us today to talk to us about MBE, or Model-Based Enterprises. Actually, until a few days ago, I had no idea what MBE meant. Actually, I did like pretty much what everybody else do. I went online, Googled it, and I guess like Chris is going to show us in this presentation, it's a little more than just Googling it that will make you understand what MBE is, because there's a lot of acronyms out there. So I'm just very excited to learn about MBE today. And we have Chris here with us. So Chris has a master in mechanical engineering from the University of Rochester with a BSME from the University of Connecticut. He has over 37 years of experience in the industry, ranging from Kodak, General Motors, Torrington Company, Otis Elevator, and he's been now with Medtronic for over 10 years. Chris has worked in many industries from metrology, quality, design, manufacturing systems, advanced analysis, and he's really kind of managed a lot of groups, various groups of technical resources. Chris is currently a distinguished R&D engineer at Medtronic in North Haven, where he drives and mentors engineering best practices and robust design throughout the product development process. So Chris, welcome.
Thank you.
Thank you. A few other things just before I forget. This session is being recorded, so you will get the recording after the session ends. We'll address any question you have throughout the presentation at the end of the presentation. And if for some reason we run out of time, Chris will make sure to address them, in advance of us sending you the recording. So with that, Chris, the mic is yours.
Great, thank you. All right, let's see, we'll get going here. Let me know when you can see the first slide. That should be coming through. Okay, you can see that, Severine?
Not yet. I still see the CDC slides.
Okay, let me try that again. Screen one, share.
You got it.
Okay, very good. Well, thank you again. Welcome, everyone. Thanks for joining. Again, my name is Chris Caswer, and what we're going to present today is going to talk about managing your data and improving your bottom line. And the content I'm going to share was also put together, some of the content put together by a couple of my colleagues, Blair Donowald and Jason Williams. So I wanted to throw a shout out to them for their effort too, and as the three of us have worked on this topic for a number of years. So what we're going to do is we'll have a little introduction, talk about some definitions, maturity levels and index values for the system, and then some benefits in QA. So the first question we've got is, have you ever had a situation where you've got conflicting engineering specification data? Right? So maybe there was a difference between a dimension on a print, and maybe that dimension had to be verified by the quality organization as part of their inspection plan. Maybe, for instance, as a specific example, there was a rib thickness on a drawing, but somehow the CAD model that is, for many of us, used to feed a CNC program did not contain that rib, right? So there's this mismatch between the data that we've got, right, from two different sources that are supposed to be the same. So then the next question is, well, what if it's possible to reduce that number of data sources to something more manageable? And maybe a data format that we might be able to view with our own eyes, and then also have it understood by anyone and anything that needed to consume it. So we'll start off with our first definition. And, along answering that question, we have to ask, well, what if there was some kind of an enterprise system, right? That a number of different organizations that needed to use that data could be put together around a comprehensive data file. And maybe that data file is model-centric. And along the way, I was told there was something like this that was called MBE. So as some of you may have done, you might want to go and do a Google search. So if you do that, at least when I did it, and this was the actual first result that came up, MBE stood for Member of the Most Excellent Order of the British Empire, right? So we've got Ed Sheeran showing up. We've got Adele, and then we've got, his name just, Formula One driver for Mercedes in the picture there. I should be shot now. I can't remember his name because I watch it every week. But anyway, you see these numbers of people that you may recognize, but this isn't what we're looking for, right? So we try it again. And we take a look at some other listings down further from the Google. And we do come across something that kind of sort of maybe looks like what we're interested in, but it's not model-based enterprise, it's model-based engineering. So really didn't have a winner there. So what we'll do is we'll just plow forward and talk about the fact that for our discussion, MBE really is model-based enterprise. And so what we're talking about with model-based enterprise is to create this fully integrated collaborative environment that's created on 3D product definition. And that definition gets detailed and shared across the whole enterprise so that it would allow the development of the products from concept to disposal to be much more efficient and effective. So one thing that MBE is about is sharing this data, again, across the whole enterprise. That can include simulation models that will update. That has some subsets of data that you may have heard of, referred to as digital twins. You can have virtual repair models, assembly process videos. All of these are possible to be created and point back to one set of data that will update all these elements as the model is updated. We also have characteristics that can flow to and from requirements management tools. Of course, we'd want to be able to reuse the engineering data for work instructions and illustrations. And then bills of material too should be updated through the system, the BOMs and the MBOMs and the EBOMs. Also about being able to communicate and share with others, right? So producibility, manufacturing, procurement, quality, support. Again, it's really going after the entire enterprise and coming up with a means to be able to share this data. It's also about supporting the supply chain, right? So we've got cross-disciplinary groups that will all have access to the same information. The engineering data can be aggregated in a central location, right? So we want to share one piece of data. We only want to store one copy of it, right? Because as soon as you have two copies, you might question which one's the real one, the most up to date. Also, you'd have full access to all the aspects of the engineering and decision data, right? So again, we're talking about an enterprise system that is storing, managing, controlling one source of data for defining the product, along with any other ancillary pieces of data that get tied to it. And when we take a look at this kind of a system, you end up realizing that one of the foundations in the hub of model-based enterprise is what we call model-based definition. So let's take a look at Model-Based Definition. MBD is what it's referred to. So you might hear MBD talked about, and there's actually a couple relevant definitions for MBD. The first one, which I'm sure is older, is called Model-Based Design. And this is where we would use the CAD model to conduct engineering calculations. Right? So we're looking to understand stresses, kinematics, loading, torques, and we can use the 3D CAD model to run those studies and understand the behavior and how we might want to redesign any components and assemblies so that we can drive toward the proper performance. So here's a couple just static pictures. You know, we've got an FEA here on the left, lower left. We're using the CAD model, right? So this is the same CAD data that we're using to create a drawing. We're using it to do a study on the behavior. And then in this lower right-hand image, showing a picture of some dynamic loading results that were run for a little gear train and some bearing supports and showing the different loads. So again, it's about using the 3D CAD data to actually conduct virtual experiments to understand the behavior. The other MBD definition is Model-Based Definition. And this is, again, that hub of Model-Based Enterprise. And this is where we use the 3D models to effectively contain any and all of the data that would be required to define the engineering design intent, manufacturing information, along with quality requirements. And as you drive toward an extreme in a very mature model-based enterprise, the formal and familiar 2D drawing file gets replaced with a three-dimensional version in MBD. And it might be mimicked through other means, such as a 3D drawing or a 3D PDF. So, you know, this new replacement for the old 2D drawing can come in the form of a number of different formats. And as a side note, that's where some of the challenge comes in putting a system like this together, is that there are a number of ways in which we can do that. So that's challenge number one. So the information, right, that we typically have a drawing, dimensions and notes and whatnot, and any other specifications found on typical 2D drawings are now going to be included in the 3D model. The approach does not eliminate the need for the information and provides machine readable capabilities. So this is a key statement here too in the creation of these MBD files. We're not eliminating the need for the dimensions to be shown, but we're placing them in the model and identifying them visually so that, you know, humans can see them, and so that it's done in a way that machines can also read these, right? So typically we might give step files out to manufacturing organizations, and they'll take those and feed them into a CNC. Well, the information that we want to put into these 3D models is similar in the sense that we want to make sure it can define what the machines need to read and understand so that it's consistent. So now, obviously, you can, putting these couple bullets together, you come to the conclusion that we're now creating an authority in the model, right? We're looking to one source of data now that can drive all the different engineering activities. And the 3D model that gets augmented would then become a primary part of what would be called a complete technical data package, or TDP, that is within the model-based enterprise, right? So as we've talked about kind of these building block pieces, we can see that all of this is feeding into this enterprise-wide system where now we can take one piece of data share it amongst a number of different groups and still have all those groups understand exactly what it is you're trying to accomplish. And again, highlighting that the 3D model with this included PMI, or product manufacturing information, would be readable by both human and machine for all downstream use. Right? So you pull up this file, whether it's a 3D drawing or a 3D PDF, there's HTML versions. When you open that on your computer, you'd be able to see and consume any of the information you'd need to understand the design intent, how it might be manufactured, quality, inspection requirements, but it would also be machine readable as well. And that's the goal. So here are a couple examples, just some one simple part that kind of shows to demonstrate what the CAD model itself would look like. On the left side, we have an image of a bearing race. It's, of course, a static image from the computer, but it's in the CAD tool. And the interesting thing about it is that all the different subsets of information that you would find on a 2D drawing could be located and easily managed by a main view, and then simply clicked on any of these items to jump to it. So in this example here, we've got just the home page and the map of the part. In the actual CAD tool, if I were to click on this bottom selection, data section A, it would jump to this view, which is a cutaway, and you can see now all of the dimensions that are included in the part. So as you can imagine, this right-hand view is something that is very close to what you might see on a drawing that would specify the dimensions for this bearing race. And when viewed in a 3D viewer, you're able to rotate and take a look at the model from different angles. You can query what surfaces the specifications are pointing to. So there's a lot more information in viewing this type of file as opposed to a 2D print. Okay, so now we've got a couple of the building blocks laid out and put together. Let's take a look at model-based enterprise from kind of a maturity level, if you will. And this topic and these maturity levels have been put together over quite a number of years. This index comes from NIST. There's a link here that you'll have in the slide deck copy you can find. And what this does is it goes through the different levels of maturity that you could have to kind of tie in where you might be to your journey along the model-based enterprise ladder, right? So at level 0, you're working with 2D static drawings only. A 3D model might be ad hoc. The models themselves aren't managed, and of course, they're disconnected, right? You've got some file sharing, and the 2D drawings are the authorized element. And then you move up level 1. Now you've got 3D models that are creating 2D drawings, right? So all the 2D drawings have some associated 3D model. And then there are some other outputs that you can have, step files and different 2D drawings that can be output. Maybe the models are managed. And as we go up through these different levels, you see that there is more weight put on the 3D model itself. Level 2 talks about creating drawings and derivatives. The models themselves are being checked, right, and compared and managed. There's a certificate of model quality. And so now we're getting to the point where we want to scrutinize the quality of the model, because it doesn't just act as a tool to create a 2D drawing. It's actually containing the real information that is going to be looked at directly and shared down the line. Level 3, we start to talk about model-based definition. where we have 3D PMI, the product manufacturing information. We have other metadata that's included. You have 3D interactive viewables. So as you can see, we're starting to progress and become a little more sophisticated in the way in which we're using the 3D CAD data itself. We also take a look at managing this through a part-centric product lifecycle management tool. Now, at the bottom, you still see that 2D drawings are still the authorized element that everyone refers to. And then there's a big jump here from 3 to 4, where the 3D model is now what is authorized. And so we're getting into a little bit further and deeper use of that 3D data, but now we're controlling it directly. And level 5 adds more elements of sophistication, sharing it with other different groups to a higher level. And level 6 is the highest level that's been put together and agreed upon across different organizations. Model-based definition with the requirements now, right? So now the enterprise can take a look at the requirements of those parts. You have an authenticated digital exchange. So we're really going to the extreme in managing this. And as you can imagine, you really need to take this one step at a time. This is a very complex system at level 6, and you need to step one level at a time and build out your capability as well as your skill set in handling the different data types. So for instance, you may go back, you may pull this up when you get to work, and you may start checking off different areas that you know you're conducting now. So you might go through and say, oh, well, we're already at a level 1, for instance, and we happen to be making 3D models that create drawings and some derivatives. We check some of our models, we might manage them, but we don't do some of the rest of these things. And then maybe we happen to have some kind of PLM system that does take a look and manage the life cycle of those parts. So you might have kind of a disjointed set of activities you're conducting now, but you'd only really be able to say that you're solidly operating at a level 1. So that would be the first step, would be to take a look and evaluate where you are, and then find out which pieces you aren't currently able to create, manage, or control. And then that would be the starting point for you to then move to the next level and then prepare yourself for the levels beyond that. So what would the benefits be if we were to introduce a system and go down the path of model-based enterprise? Well, one would be the development cycle. So typically what has been found across a number of companies, and the model-based enterprise has been around for quite some time. Model-based definition has been worked on by a number of the major CAD companies for the last 10 to 15 years. A number of government contractors have been driving toward this, and a number of other private industries have been working on it. So far, the folks that are reporting any information are talking about a 20% reduction. Of course, you're reducing the time to design, manufacture, and inspect, because now you can trust and rely on that data to be consistent. You're going to shorten the delivery times to the customer, right? Because you're reducing the times to design and manufacture and inspect. From an engineering standpoint, you get a reduction in time spent creating drawings. Typically, what's been found is annotating the models in 3D as opposed to creating a separate file that's a 2D drawing can save sometime between 5 and 50% of the time, depending on how complex it is. The time spending to clarify the drawing with the shop is almost eliminated And I can tell you that we've done a little experiment with our local prototype shop, and we gave them some parts that were created with 3D drawings, 3D drawing elements, and they really liked working with that data in that way because they could spin, zoom in, and look at the part, and they understood exactly where the dimensions, what geometric features were being referenced by those dimensions. So there's definitely a lot of value there. Next generation of labor force is more comfortable with 3D models, and sometimes cannot read traditional drawings as easily. So there can be a challenge there. From the manufacturing side of things, we have the opportunity to reduce scrap and rework because of misinterpretation of the drawings. Again, they're able to look to find out exactly what surfaces. And again, the CAD tools have been developed to add capability that feed off of this approach, right? So you put a dimension on a part in 3D, you actually select the surfaces, and those surfaces will highlight when you select the dimensions. So there's no question as to where those dimensions need to be fixtured and machined. You're going to reduce the time waiting for drawing clarification, right? Again, because it's a clear set of data that's understood. From the quality standpoint, you can see a savings for inspection through CMM or probe programming because the process gets streamlined. Some people have found 10 times savings because the information for inspection is part of the CAD model. And again, the surfaces are known as to where those dimensions go to. So the programming can be done very easily. Non-conformance reduction has been found to be up to 30% of scrap because, again, of drawing issues. We have that mismatch problem looming out there. I'm sure many of you have seen where the drawing doesn't match the model. So that's the goal, is to eliminate that. The funny thing about this whole journey toward model-based enterprise is that most every company feels that it is a competitive advantage. And so they're very reluctant to share data publicly. What we've got here is kind of compiled through different presentations from different companies, putting a little bit of a twist on it so that they're not showing everything. Because again, it really can be a huge competitive advantage. So tough to get a lot of good data on. There was a med device company that did share their digital journey in a forum, an open forum. And what they found, again, some generalizations, was the greatest efficiency was realized through traceability from requirements to final design. Right back a few slides, we talked about how the requirements for the product can also be part of the model-based enterprise, and we can share those and tie those back and forth to the CAD data. Also, reduce paperwork through automation and optimized processes in their PDM PLM system. And the focus on model-based definition and model-based design was also where some efficiencies were realized as well. All of these together led to anywhere from a 40 to 60% reduction, depending on the programs they were talking about, in the entire new product development life cycle. So that's pretty significant when you're talking about half the time to get a product developed. And some of my personal experience across different companies have shown the same kind of thing. When we created the CAD models with the knowledge that they were going to be used for other downstream purposes and not just to make a 2D print, we put more attention and more focus onto the quality of that model, and we were more easily able to use it for those other downstream purposes and point to it all the time. So it definitely saves a lot. And as always, the road to success is under construction, always under construction. And I thought this was interesting. Lily Tomlin came up with this. So with that, I'd like to take any questions and comments from anyone.
I don't know if there's any question left, but I think, one of the questions I have is definitely, what are the biggest challenges in really like implementing and realizing MBE from your experience?
Yeah, so I think, when we take a look at model-based enterprise and the foundation of it, we're looking back to the CAD model, and there's definitely going to be a shift, could be a very large shift in how that data is put together, right? When CAD tools first came out, they were meant to be able to visualize the parts, be able to make assemblies, take a look at what it looks like, find out what the total mass, center of gravity, and of course it was used to make a 2D drawing. But there really wasn't much thought at that time to what else it can do. And, over the last 30 years, we've seen so much more capability put into those models that we're to the point where it's possible to add all this information. And so one of the biggest challenges is just making that pivot and shift to a different discipline and realizing that the CAD model is going to be created for much more than just making a print, much more than maybe conducting a stress analysis or a mechanism. We want it to contain information that the manufacturing organization and the quality organization and everyone that needs to touch it can actually use it and rely on the fact that it is the source of truth. So, it's going to be consumed a different way. So that's another challenge. People aren't going to be able to just open up a PDF file and look at a flat, what would be a flat piece of paper on their screen, a representation of, and try to pull dimensions and requirements off it. They'll actually be able to pull that model up and rotate it, look at different aspects of it, look at different, pieces and segments and different windows. So there's a very large change in not only how we're going to consume it, but how we're going to create it so that the consumption is clean and without error.
Actually, one of the questions would be about your email address, Chris, and I believe that we will share that as well. So if there's any questions, they will go directly to you, correct?
Yes, yeah, we will be sharing my email in the, I guess when you send an email with the recording, yes. So
exactly.
Sure, if you have any questions, please feel free to send me an email. I'd be happy to hopefully be able to answer it.
Yeah, another question. I think from a software standpoint, have you seen any specific software that are really enabling MBE, or are the software keeping up with MBE? What's what role? Because my understanding, they play a pretty big role in MBE. So anything from that standpoint you'd like to share?
Yeah, sure. I'll refrain from actually giving any names out, but because I'm only very familiar with just a couple, and I know there's a lot of them out there. As far as software goes, one aspect that we didn't talk about was how does that data get validated? How is it checked, right? Because you can make a print, you can print out a 2D drawing, and it can have a certain revision and date. And as long as everyone knows they're working off of that, that's the actual data, and all the dimensions are on it, the materials are on it. And so now if you're going to share 3D data, there are a number of formats out there, and they've been developed over the last 10, 15 years. And certainly as soon as you have a second format, it's now a competition. So they all are striving to be able to contain all the information. There are some out there. The QIF format is one that comes to the top of my mind, where they have gone and created an internal check to make sure that during the translation, the 3D data does get converted, and they check that for size and shape. So there are a lot of companies out there that are working toward that goal, so that the data is validated and it gets generated into a format that's easily readable and opened up by people through sometimes free readers that you can open that data. The QIF format also, among others, can offer the ability to store the actual measured data. So if you've got a part, you've got all your dimensions to it, you can also include the dimensions that need to be checked from your quality plan. And these data formats can store that information. So there's some pretty interesting, powerful capabilities that are being developed to generate the data, provide more capability to the data in order to be able to realize those different levels in that maturity matrix we talked about, from going beyond just design and manufacturing, but having quality, regulatory, and all those folks be able to view that, use that, and make sure it's the one source that has everything they need. Yeah, so I see there is one question from Jason Liu about the model validation process. Yeah, and so that is definitely one of the biggest challenges. Again, there is software available. There are a few companies, I don't know how many, but I know of two anyway out there. One format does do the check. Another company actually goes in and interrogates the native CAD model and interrogates and compares it to the neutral format that it creates for consumption, to make sure that the geometry and the sizes are all within whatever tolerance is allowed in that verification. So, and all those, as I said, they're competing technologies, and at some point you'll see, and they're coming out now, standards. Down the road, I think we'll probably migrate and end up with one or two that are accepted and that can be used. So definitely more to come there. I'm not close enough to that to know if anything has been selected, but it's definitely, it's not a trivial topic, but they're working on it, and I've seen some really nice examples that seem to be working well.
So I guess that's a pretty long process, right? To get to a maturity stage 5 or 6.
Oh yeah, it is. It's in companies have shared that it's many years. You know, some can take 4, 5, 6 years or longer. It just depends on the resources you've got, how you're going to split up your skill set, and the training involved, and the understanding of how the data gets generated. But, you know, as I mentioned, I've seen some small pieces of this seem to work very well. So definitely, you know, one step at a time, you'll realize the improvements and the benefits, taking it one piece at a time and build on it. And, you know, quite honestly, it's okay if people end up at a level 3 or a level 4. There, you don't have to go for a level 6, but certainly level 6 is the endpoint that encompasses as much of the enterprise that needs to deal with data as possible. So 6 is the extreme, and a 3 is probably a really, really good start to maybe even hang out for quite a number of years, because you'll reap some benefits from even a level 3.
Well, thank you, Chris. I don't see any more questions right now. So as I mentioned, you'll get the recording with the info from Chris. So you can, reach out to him after the fact as well with some questions. Just a reminder, our Tech Talks are back monthly now that the summer is over. It's typically the second Tuesday of every month, but with Labor Day, we push this one a little further. So, stay tuned to know what the next topic is, and we hope to see you and a lot of your colleagues here on the next Tech Talk. So thank you, everyone.